On this day, a remarkable journey began and changed what humans could accomplish beyond Earth.
This map shows Apollo 11, 12, and 14 clustered near the lunar equator. The U.S. won the geopolitical race, but exploration remained limited. Encumbered by bulky pressure suits, astronauts were confined to short walks within an isolated radius of their landing craft. Because they could not safely travel far from the module, the vast geological history stretching across the lunar surface remained entirely out of reach. To gather deeper scientific data, NASA shifted its strategy. They introduced the J missions, a directive moving toward extended, heavily equipped scientific stays. Fulfilling that directive required overcoming the limitations of the human body. Doing so meant delivering a massive, heavy payload safely to the lunar dust. On July 26, 1971, the massive scale of the Apollo 15 launch provided the necessary thrust to lift that heavy scientific payload into orbit. The crew responsible for executing this transition consisted of Commander David Scott, Command Module Pilot Alfred Worden, and Lunar Module Pilot James Irwin. Their destination was the Hadley Apennine region, a rugged, mountainous area that demanded highly precise navigation and supported an extended surface stay. To explore this challenging terrain, a critical new piece of engineering was folded and packed tightly against the side of their lunar module, the Lunar Roving Vehicle. The addition of this rover shifted the primary challenge of the Apollo program. The goal was no longer to simply arrive on the moon, but to actively navigate it. Following a successful orbit and descent, the crew found themselves in a stark, heavily cratered environment, marked by the extreme isolation of the mission. Down in the Hadley Apennine landing zone, the monochromatic terrain was deeply shadowed by towering, ancient mountains. Once on the surface, Scott and Irwin initiated the mechanical unspooling sequence, deploying the folded Lunar Roving Vehicle directly onto the fine lunar dust. The moment those wire mesh wheels touched down, humanity established a mobile outpost on another world, increasing the territory accessible for scientific study. Before launch, geologist Dr. Leon Silver trained Scott and Irwin extensively on Earth. He taught them how to identify geological formations with technical rigor, rather than simply collecting random rocks scattered across the surface. The rover served as the perfect tool for this observational science. It allowed the astronauts to rapidly traverse diverse terrains and hunt for specific, high-value geological targets. This diagram compares earlier constraints to their new capacity. Instead of a tight 1-kilometer walking radius, Apollo 15 executed a sprawling 27.9-kilometer driving route. Beyond transporting the crew, the vehicle served as a communications platform, beaming findings directly back to Earth via a high-gain antenna. The physical evidence of this mobility was etched into the dust, with sharp parallel tracks cutting through a landscape undisturbed for billions of years. Combining rigorous, earth-bound geological discipline with mechanical mobility, the crew operated as the first true field scientists on an alien world. Lunar field geology required precise physical processes. Using long-handled tools and clear plastic bags, the astronauts gathered uncontaminated samples from the terrain. Their extended driving range allowed them to reach the deep slopes of the Apennine Mountains, exposing them to ancient crustal materials inaccessible on foot. Deep along these slopes, they discovered the Genesis Rock, a piece of the moon's primordial crust. Before moving any specimen, the crew documented its original context and position using chest-mounted Hasselblad cameras. This image shows a collected sample under laboratory measurement. Anchored by the Genesis Rock, the 77 kilograms of material recovered by the crew provided researchers with the data necessary to understand the moon's origins. The scientific yield of Apollo 15 dwarfed all previous mission collections, proving the effectiveness of the J mission directive. As the crew departed, they left the Lunar Roving Vehicle parked on the surface, a lasting monument to human engineering. The mechanical reliability of that first rover provided the engineering basis for the robotic and human vehicles used in modern planetary exploration. The July 26 launch removed the physical constraints on human exploration. It shifted spaceflight from geopolitical competition to a sustainable model of scientific discovery.
Apollo 15 turned lunar exploration into mobile field science. If you found this interesting, please like, share, and follow On This Day with Mara for more stories from history.